Welcome to Geometry, Unit 9, Section 1. Circles and circumference. You spin me right round, baby, right round, like a record, baby, round, 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 round. That's how that song goes. It was rocking in 1985. Okay, so first we want to do a definition. So a circle is the locus or set of all points in a plane equidistant from a given point called the center of the circle. So the center of this circle is point C, and all the points in green are equidistant from C. Okay, a radius is a segment with endpoints at the center and on the circle. So segment CD, segment CE, and segment CF are all radii of circle C. You'll notice how we can write circle C here, right? How we can, this is the symbol for circle. It's a circle with a dot in the middle. Okay, excuse me. A chord is a segment with endpoints on the circle. So in this case, segment AB and segment DE are chords of circle C. Okay, a diameter of a circle is a chord that passes through the center and is made up of collinear radii. So segment DE is a diameter of circle C. The diameter segment DE is made up of collinear radii, segment CD and segment CE. Okay, let's identify segments in a circle. Okay, so we're going to name this circle. Well, that's pretty easy to do. You go to this center point right here in the middle, and we would call this circle P. All right, P is the center of the circle. Okay, radii, all the radii in this circle have to have the letter P in them, right? So when we name these segments, so it's pretty simple. I'm going to name all of them. Segment PL, segment PM, and segment PN. Okay, if a circle has a radius r, right, the variable r, and the diameter variable d, the following relationships are true. Radius formula. So if I am given the diameter, so to solve for the radius is equal to the diameter divided by 2, or the radius is equal to 1/2 times the diameter. If I'm given the radii and I want to find the diameter, I just multiply the radii by 2. Okay, so we want to identify a chord and a diameter of the circle. Well, there are two chords in this picture, so I'm going to name them both. The first is going to be segment JK, and the second is going to be segment HG. All right, it's got to go on the circle, right? The diameter, there is only one in the picture. So the diameter here would be segment HG. Okay, if segment QV is equal to 8 inches, so this is 8 inches, what's the diameter? Well, to find the diameter, if we're given the radius, so remember diameter is equal to 2 times a radius, and since QV is a radius, the diameter in this case would be 2 times 8, which would be equal to 16. Okay, so congruent circles, two circles are congruent if and only if they have congruent radii. So if segment GH, given that segment GH is congruent to segment JK, then circle G would be congruent to circle J. Okay, all circles are similar. Why? So all circles are similar because, first of all, they have to have the same exact shape, and all circles have the same exact shape. They're circles. Okay, concentric circles are coplanar circles that have the same exact center. All right, I have circle A with radius segment AB, right, and that would be the smaller circle, and circle A with radius segment AC, that is the larger circle, and they're concentric. Think of a target, okay? That's a bunch of circles that get smaller, right? Those are concentric circles. Okay, if two circles intersect, all right, they can have 2 points of intersection. So we can see here in this set of circles on the left, we have an intersection right here and an intersection right here. In this one with a smaller and larger one, we still have 2 circles that intersect in those 2 points right there. Circles can also have 1 point of intersection. They call this a tangent. All right, this is exactly 1 point right here and one right here. Those circles intersect, they just touch in that 1 point. Okay, so they can be 2 circles that are outside of each other, or 1 circle can be inside of the other and touching. We can also have 2 circles that don't intersect at all. So the 2 on the left, they don't have any, they don't meet at all. Or you can have two concentric circles, and those circles also have no points of intersection. Keeping in mind, the circle itself is just the green line, curve, whatever you want to call it, that goes around. Okay, that's the circle. What's inside of the circle, that's called the interior. That is not part of the circle. All right, so we're going to do an intersecting circle measure problem. So the diameter of circle S is 30 units, okay? So we're going to go and we're going to mark this up here. So this distance here is 30. The length from D to S is 9, right? All right. Oh, excuse me, the diameter of circle R is 20. So this one here is 20, and this is 9. So we want to find the length from C to D. Well, if we know that the distance from D to S is 9, right? First of all, this distance here, this radius, half of that has to be half of 30. That has to be half of 30, so that's going to be 15. So this piece from here to here, all right, it's got to be 6, right? So CD is equal to 6, okay? The easiest way to do these problems is to mark up the diagram that's given to you. Or copy it down as best you can and then mark it up. Okay, if a circle has diameter d or radius r, the circumference c equals the diameter times pi or twice the radius times pi. Again, the circumference is the distance around the circle, right? Starting at a point, we go around until we return to the given point. All right, so c equals pi times d, or c equals 2 pi r. So let's do some circumference problems. Okay, so there's two ways we can find circumference, okay? One is to find it in terms of pi, and the other one is to find it, may say, rounded to a nearest hundredth. So in this first one, 2.5 times the radius, right? So 2 times pi, right? This is we're given the radius, so the circumference is equal to 2 times pi times r. So we would say 2 times pi, well, again, well, we didn't have to use parentheses, but we will, times a radius of 2.5. So this gives us 2 times 2.5, which is 5 pi. Okay? So in terms of pi, you can stop right there. Okay? If we're given a calculation, let's say we want to say, okay, let's find this to the nearest hundredth. So the circumference, we would just take our calculator and put in 5 times pi, right? Right. Here we go. 5 times pi, and I've got 15.707, which would be 15.71, right? So this would be, we would say 15.71 would be rounded to the nearest hundredth. In terms of pi times the diameter, right? This would be equal to pi times the diameter. So circumference is equal to basically to 16 pi. And we could stop there if it's just in terms of pi. But then if they're asking us to round to the nearest hundredth, we just take our calculator and do 16 pi. And I've got 50.265, so we'd say 50.27. All right, now they want you to find the diameter and the radius of a circle to the nearest hundredth if the circumference of the circle is 106.44 millimeters. So circumference is equal to pi times the diameter, right? Because we're going to find the diameter first. So I know the circumference, that's 106.4, is equal to pi times the diameter. So I'm going to divide each side by pi. Okay, these would cancel, and I get D. Okay, so you take your calculator and you punch in 106.4 divided by pi, and you end up with 33.868, right, to the nearest hundredth. So that would be 36.87. 33.87, excuse me, not 36. 33.87 is the diameter. Well, now to find the radius, we just divide that by 2. And I've got 16.934, so 16.93 is equal to the radius. Okay, a polygon is inscribed in a circle if all of the vertices of the polygon lie on the circle. we would say the circle is circumscribed around about a polygon if it contains all the vertices of the polygon. So we can take a look here at this diagram, and we have quadrilateral LM and P, and it is inscribed in circle K. To look at this from the other side of the thoughts, circle K is circumscribed about quadrilateral LM and P. Okay, a square with side length of 9 inches is inscribed in circle J. Find the exact circumference of circle J. All right, so if you remember, we're going to incorporate some of our work from our prior unit with right triangles and special right triangles. So we have here, this is an isosceles right triangle because this is also 9 inches, right? So this makes this a 45, 45, 90 right triangle. And the ratio between the leg to the hypotenuse, so leg to hypotenuse in a 45, 45, 90 right triangle is in the ratio of 1 to square root of 2. So you multiply the leg by the square root of 2 to get the hypotenuse. Well, in this case, this hypotenuse is a diameter of this circle. So we're going to say 9 is the leg, all right, times the square root of 2, and that's equal to the hypotenuse. Okay, so now this distance here, this whole thing away across is 9 square root of 2. Now I'm going to take this and find the circumference. So the circumference is equal to pi times the diameter, which is 9 square root of 2. So now we just plug all this into a calculator, right? So basically I can take my calculator and say pi times 9, and then I would put my square root of 2 in there, and then close my parentheses, and I end up with 39.985. So the exact circumference here would be that's not an exact circumference I'm giving you. So the exact circumference would be 9 pi square root of 2. The approximate circumference rounded to the nearest hundredth would be 39.99. Okay. So this is an exact value, 9 pi square root of 2, because we're going to end up with a bunch of decimal values and pi's involved, so it goes on forever. But for our sake, at this point, we're going to round it to the nearest hundredth and just say 39.99 is our circumference.
That's all, folks.